This video we're going to see about the plate type heat exchanger working. So here's the split up open section of plate type heat exchanger. What you can see is the arrangement of different plates and the end and pressure plates of plate type heat exchanger. So with this in mind, we will just look at the operation and simple construction of it. There is a base plate which is called as a frame plate or end plate, which has 4 holes just for the inlet and outlet of the cooling medium or the hot and cold fluid. So 2 for the hot and 2 for the cold, or the liquid which is used to cool the hot one. So and you have a groove upon which the gasket is being fitted with a glue or something what the manufacturer specifies, and you have 100 or 200 plates depending on the size and capacity mounted on the frame plate upon the tie rod. The tie rod runs from the structure, that is the equipment, the heat exchanger's body, right through a long length, so that the pressure plate which is at the end can be mounted, and upon this tie bolt the nuts can be tightened. The manufacturer usually specifies the compression length of all the plates together with the number of plates, or sometimes he specifies the torque value of the nut to be tightened. So let's now see how does it work. Let's say the blue one is supposed to be the fresh water. Let's say it's from the LT or HT system, which is coming at 90 degrees, and we want to cool it down to 60 degrees or 70 degrees. So this water enters through this hole and then it climbs up, and it cannot go through these 2 holes as the O-ring seals it off, and then there is a way for here to the outer hole. It can go through this. The fresh water can flow from here to here, and these 2 holes are sealed off by this O-ring, so it cannot flow. And then it passes through this hole. It cannot enter this plate as here the O-ring seals off the freshwater side. There's a difference between this plate and this plate. The end plate has access to only these 2 holes, as other 2 holes are sealed off by the O-rings, and this plate is having access only to the seawater side, and other 2 holes are blanked off or sealed by the O-rings. So in a similar way, the seawater or the fresh water passes on to the next plate which has access, that is the O-ring is not sealed, so it can flow through this plate and this plate. So you can simply assume that the fresh water can flow every alternate plate. Let's number this plate to be number 1, and it will flow in number 1 plate, and number 2, no, it will not flow. Number 3, yes, it will flow. Number 4, it will not flow, and number 5, yes, it will flow. So every odd plate the fresh water flows. It's represented in blue color. And let's now look at the seawater side. The seawater enters from top at this place, and then it cannot enter here and pass as the O-ring seals off here, as I mentioned earlier. So it passes on to the next plate, and then it goes to, from the top it goes diagonally opposite to the bottom-most hole. So now you can look at the heat exchange process, or the direction of flow of the 2 fluids. The fresh water enters here at this hole, which is bottom left corner, and then it climbs up and goes to top right corner. But when you consider the seawater, it enters from top left and goes out through the bottom right corner. so it's diagonally opposite, and it is this type of flow which gives better heat transfer efficiency. And then it goes to, let's say this plate is sealed off, and then it goes to the next plate where you have O-rings here, and then it continues, and the pressure plate also has O-rings. So with respect to this diagram, the seawater enters, it cannot pass through this plate, and then it goes and then comes down and then returns back. So this should be the last plate upon which the seawater flows. So when you look at the plates in detail, like each plate is corrugated for obvious reasons to improve its strength, and as you all know, the plates are made of material called titanium, and that's having more strength and to resist corrosion. And apart from that, the compression length of the entire set of plates is very important, as I said earlier, to make the leakages, or there should be no leakage when you tighten it perfectly. And the manual says the tightening sequence of the bolts, so it's better to follow those tightening sequence, otherwise there would be a leakage. So whenever you open, you might find some of the gaskets coming off its screw. So for that we have special glue, which is something like, you can't use normal adhesive, as it'll come off when it goes at the working temperature. So the manufacturer gives a special glue for it. We can use it and then fix or press the gasket, and then leave it for at least 30 minutes to 1 hour so that it dries up, and then you can fit it up. So that's it about the plate type heat exchanger. We'll see more about the plate type and shell and tube type heat exchanger and the expansion arrangements in the future videos.